Okay, to find the p-value of 0.3, we're going to use the normal distribution function on Excel, but because we're looking for this upper tail, this greater than this particular number, like we did back in chapter 6, we have to do 1 minus whatever the probability is, because when we look up the probability, it's going to be over here. Remember, it always reads to the left. So if you're looking for the little tail area that's on the upper end, the upper tail, then you always have to do 1 minus, and then we'll do our normal distribution. Okay, and we're going to be doing that of 0.3. You just plug in your z-value. So you'll type the formula in Excel, 1 minus, and then the function of normal distribution of 0.3. And when you put that into Excel, you end up getting a p-value of 0.3821. Okay. Now we'll use the table that we've seen lots of times over on page 385. If the p-value, and this time our p-value is greater than our level of significance, because this problem tells you in part C that your level of significance is 0.05. So our p-value, which is 0.3821, is greater than the 0.025. So therefore, we're going to accept our null hypothesis. So we didn't reject this time, we accepted, and so we did prove, when you accept, you're always accepting about the null, that the population proportion is in fact less than or equal to 12.5%. Now really what it was asking us to prove was had it increased, but we proved that it had not increased. Even though it looked like it increased some, but it wasn't a significant enough amount to prove it otherwise. So you have to assume that the null hypothesis is true unless you have it to prove something otherwise. It's kind of like a court of law. You're innocent until proven guilty. The null hypothesis is true unless it's proven otherwise, and that's not enough difference to prove it otherwise. So I hope that makes sense. Hope that helps you through chapter 9, and be sure to let me know if you have any more questions.